Very quickly now we will introduce the concept of magnetic flux, quickly because you've heard of flux before in the context of electric fields. All you need to do now is swap out the electric field with the magnetic field. So we'll label a subscript B for magnetic flux. The flux calculated through a surface is the dot product of B dot dA integrated over the surface. Ultimately, that takes the form of the perpendicular component of the B field times the dA magnitude. That's what this dot product gives you, where it's the magnitude of each B dA times the cosine of the angle between them. This is valid, once again, for any open or closed surface. We all know how to compute flux at this stage, flux of a vector field through a surface. If you look at the bar magnet example, it looks like a magnetic dipole. Remember, we had a north and a south pole with a dipole moment vector that points from south to north. We know that there were closed loops that the magnetic field would form. We know they may not begin or end on an object because we have not yet discovered north or south magnetic charges. Sometimes these are referred to as monopoles. Various experiments through history have searched for these and have yet failed to demonstrate evidence of their existence. But the lack of evidence for their existence is not proof of their non-existence. We can calculate flux through an open surface, fine. We can also calculate flux through a closed surface, a two-dimensional surface that encloses a three-dimensional volume, just like we did with Gauss's law. Now, because there are not, in this course, any magnetic charges, what would Gauss's law look like for this closed surface, S? You would have integral of B dot dA equals the magnetic charge enclosed. Well, we haven't found them yet, so we're going to call that right-hand side 0. This is another one of Maxwell's 4 equations. We will tie them all together to introduce the electromagnetic waves a little later this semester. Another way of stating this is that all magnetic field lines which pass into a closed surface S must come out. The units of magnetic flux are simply the unit of magnetic field, the Tesla, times the unit of area, which is meters squared. This has a name of Weber, and the symbol is uppercase W, lowercase b. So the takeaway here is that Gauss's law for magnetism is more straightforward. It is as if you were doing Gauss's law for the electric field and there were no enclosed charges.